Video Lecture 3.3, Atmospheric Patterns of Motion. I showed this in a previous video to showcase a dominant low pressure and dominant high pressures that exist on Earth's surface. And that low pressure located along the equator is simply due to the fact that there's 2.5 times more solar energy that reaches this area, the equator and the tropics, compared to the poles. But one of the things with that is I was trying to illustrate the fact that this isn't completely accurate. Why is it not completely accurate? We'll talk about it right now. So we're going to take this model and continue to build on it and then use it to explain the various pressure belts found on Earth's surface. We look at this, now let's try to figure out, well, what's going on with these arrows? Let's try to figure out what I'm trying to showcase here. And if we can see, in the northern hemisphere, all of the arrows are bending to the right. In the southern hemisphere, all the arrows are bending to the left. We've already explained the reasons for that. Another thing you'll notice is the arrows for the low pressure are coming in. They're going to converge with each other, which once again makes sense because that's a characteristic of a low pressure, is converging and rising air. Meanwhile, in the polar highs, you can see those arrows are leaving the high pressure. One of the things is we have these highs and lows actually in between the equatorial low pressure and then the ones in the polar highs. And so the equatorial and the polar ones, they're strictly because of temperature differences which cause those lows and high pressures. These ones in between here, the yellow and the greenish one, those are a little bit different in the sense that they're a little bit more physics, they're a little bit more mechanical as far as why the low pressures and the high pressures are existing. We're not going to go too much into that into this course. But let's go ahead and try to understand once again what are we looking at. If you look at the new high pressures and low pressures that I've added in between the equatorial and polar pressure zones still have the same characteristics. That high pressure has, in the northern hemisphere, divergence, separation, arrows leaving that box, whereas the low pressures have ones coming in. We're going to talk a little bit more about each of these right now. This here is one of the most important images we'll look at the entire semester. What we've done now is we've actually named each of these low and high pressure zones. Equatorial low pressure, that's the same one that we've been talking about that's found there along the equator, and it's also known as the ITCZ. I'll explain that here in a minute. Subtropical high pressure to the north and the south of the equatorial low pressure, and so one characteristic of the subtropical high pressure is it's going to be dry. We know this because high pressure is not going to bring precipitation, so we're going to see a lot of dry characteristics in areas that are dominated by the subtropical high pressure. Then closer to us, go ahead and throw in that yellow line, that's where we are, the mid-latitudes, we're going to be affected by low pressures. One of the things we'll talk about in video lecture 4 are these low pressures. So if we step back and look now, we got this whole snapshot of a very generalized model of the world's pressure belts, but also we can now kind of visualize why do the arrows bend to the right in the northern hemisphere. We already know that answer, why they bend to the left. Why are they different colors? The red illustrating warm meaning warm, whereas the purple warm but not super warm like you would find in there along the equatorial low pressure, meaning cold, which is going to be a key focal point for understanding some key differences from place to place here on Earth's surface. Now we'll further describe each of those 4 primary high pressure and low pressure areas found on Earth.